which you do factor by grouping when you have 4 terms. And then we talked about the 3 terms one, which that's the tough one. So this one is, how do you factor when you have 2 terms, so binomials? So if you have 2 terms, it's going to be a special factoring. It's going to be, these should be the easier ones.
You're saying 6.4 is just like
6.4 and 6.3, yeah. Remember I did those like 3 different ways. What each of them is doing it a different way. Yeah, so I didn't really, 6.3, 6.4, you just do the same. 6.5, so you got the factoring binomial. So if you have x squared minus 9, so you have 2 terms. The way this will always break down is there's always going to be perfect squares right here on both sides. So I can just break this down as in x squared, what multiplies to be x squared? X times x would be x squared. 3 times 3 would be 9. And then what goes in the middle here, since there's no middle term, if I add them up, they're actually going to cancel out. So it's going to be positive 3 and negative 3. So 3 minus 3 would be 0. There's no middle term. 3 times negative 3 would be negative 9. This property is called the difference of squares. The difference is subtract, and I'm subtracting squares. And it will always break down to be like that, where if I have x squared minus 64, you do x times x equals x squared, 8 times 8 equals 64, and then a plus and a minus. If you have a number in front of the x squared, that's fine. You're still looking for a perfect square. So 100x squared will multiply to be 100x squared times itself. So 10x times 10x is 100x squared. 7 times 7 is 49, and a plus and a minus. The very first step of factoring when we write it out is to always check for the GCF though. So if you have something like this, the very first thing you want to do is check for the GCF. What's my GCF here? Should just be 2, yeah. 4x squared minus 9. So now if I look at that, I have perfect squares, 4 and 9. So now I can break it down to 2x times 2x is 4x squared. 3 times 3 is 9, and a plus and a minus. So anytime you have 2 terms, it's going to be special after you take the GCF out. There's some other ones like this, I guess. X squared minus y squared equals 36. So here, if you have like x squared, y squared minus 36, again, you have a perfect square because I can change this one to what, xy times xy would be x squared, y squared. And 6 times 6 would be 36, and a plus and a minus. There's also the ones that are 9x squared minus 64 y squared. So again, same idea on this one. You do what? 3x times 3x is 9x squared. 8y times 8y would be 64y squared, so a plus and a minus. The one that might get you on this one is, I think of the right numbers here. This one, I think. I haven't said one thing I need to say before this, so. If I have 4x squared plus 9, 4x squared plus 9, you cannot do that because of this plus, because every other one we've had a plus and a minus right here, so it multiplies to be a negative number here. So this one is actually not factorable. That one is not factorable. So when I go to this one, what's this one? 9x times 9x would be 81x squared. 4 times 4 would be negative 16. And then I do a plus and a minus. I didn't do that the way I wanted it to. So that one works just fine. Let me go get those numbers that I want. Oh, I know what I did wrong. Oh, here, let's do this one. X squared minus 1 over 49. All right, so this one's got a fraction, but still the same idea here. I have 49 down there, which is a perfect square. So x times x is x squared. What number multiplies to be 1 over 49? 1 over 7. So 1 over 7, and then a plus and a minus. Where is it? There it is, 256. 81. All right, so this one right here. You know what multiplies to be 256? Square root of 256 is? Yes, 16. So 16m squared times 16m squared would be 16m to the fourth. So I had to put m squared because I have m to the fourth. And 9 times 9 is 81, so then I put a plus and a minus. Well, that's not quite my answer because look at this one. This one's not factorable because it has a plus, but this one has perfect squares too. And it's got a minus in there. So that could be 4m times 4m, and then 3 times 3, and a plus and a minus. So when I broke this one down to perfect squares, I added 2 more perfect squares. But I can't do that one because that one has a plus in it. Since that one has a minus, I can. So that would be your answer, yeah. All right, so the next part of this is the cubes, the difference of cubes, which is not, there's a formula for it. There's a formula for this, and I'm just going to go ahead and write out. So you have something cubed plus something else cubed. So we're still dealing with 2 terms. You have something cubed plus something else cubed. This will always break down to this, and I'm going to give you all this formula. I don't see why y'all need to memorize this formula, but the way you memorize it is there's a small binomial and then there's a trinomial. So in the small one, you put a and b. In the big one, you put a squared and b squared because it's bigger, so you do the squared. And then you put a and b in the middle. And the way you remember what the signs are is, I think it's, what do they say, SOAP. So same, opposite, always plus. So right here, this is a plus, so you do the same sign, then you do the opposite sign, and then this one's always a plus. But again, you don't have to memorize that. I'm going to give it to you. That's fine. Y'all don't do this in this one in elementary algebra, correct? Okay. I don't think so. All right, so the same thing with the minus pretty much. You have a small one, you have a big one, you do a and b in the small one. You do a squared, b squared in the big one, and then a and b. And then the signs work the same way as the SOAP. You have a minus, so you do the same sign, the opposite sign, and always plus sign. But again, I'll give you these. I don't expect you to memorize these. I don't see why you need to. All right, so how they worked is this time we're looking at cubes. So you have perfect cubes. So I would just identify what A is and what B is. So A here, A on this one is what multiplies 2 times itself to be x cubed. Just x, right? X times x would be x cubed. What multiplies 3 times itself to be -8 or 8? Just do 8. Yeah, just do 8. Let's not do the negative right now. I shouldn't have said that. So x times x times x is x cubed. 2 times 2 times 2 is 8. So that's what my A and my B are. So I go look at my formula, and I do an A, and then I do a B. I do a squared and b squared. So 2 squared is going to be 4. And in the middle, I do a times b. A times b. And then I do the same. It's a minus sign. It's a minus sign, so I do the same sign, opposite sign, always plus sign. Always plus. So really, you've got to identify these, and then you're just plugging in the formula, and we're not doing anything. This can't factor anymore, so that's as far as it goes. Plus. All right, so on this one, what is my A? 3x, right? 3x times 3x times 3x would be 27x cubed. My B would be 4. 4 times 4 times 4 is 64. So I do A and B. Then I do A squared. What's A squared? It'd be 9x squared, right? So 3x times 3x would be 9x squared. So this is 3x squared. And then B squared would be 16 because that's 4 squared. And then A times B would be 12x. Then you look at your sign. This is a plus, so I do same sign, opposite sign, always plus. That's all. That it cannot break down any more than that.
A was an A squared in the first thing.
Yeah, A and B are in the small one, and then A squared and B squared are in the big one, and A, B in the middle. I write it out in order like that because it helps me memorize. A squared, B squared, where they go. Of course, you can have ones like this: A cubed, Y cubed, minus 1,000. So here, what is my A? XY. XY times XY times XY would give me X cubed, Y cubed. What's my B? 10? 10 times 10 times 10 is 1,000. So I do A and B. A squared is going to be X squared, Y squared, because XY times XY would be X squared, Y squared. B would be 100, right? 10 times 10. And then A times B in the middle would be 10xy. This is a minus. Same sign, opposite sign, plus sign. What's the first thing I have to do on this one? Yes, those are not perfect squares, right? So I can pull out, what can I divide 16 and 64 or 54 look like? I don't think 4 goes into that. No, it doesn't. So 2. So you have 8x cubed minus 27y cubed. Well, now you should recognize 8 and 27 is perfect cubes, so that's probably right. So my A is what? 2x, and my B is 3y. So I do A and B. A squared 2x times 2x would be 4x squared. B squared 3y. 3y squared would be 9y squared. And then A times B in the middle would be 2x times 3y would be 6xy. And my signs is a minus, so same sign, opposite sign, plus sign. And don't forget your 2 out front. So that looks like everything from that section. Let's go ahead and do all the steps of factoring, and then we'll move on to the next section.